That's us, which is the SAM's update, so.
Yeah, oh, yes.
Yes, much more.
So I was here presenting to all of you in April, and I came in with all of our grand plans, what we were going to do in the remainder of the school year. So I'm here to report back to you on what we've done, and it's been very exciting. I know all of you know me, I'm Farhana DiBiase, I'm SAM's project manager. What I want to start by telling you is that this has been very exciting. I've participated in many of the classroom activities, the field trips, and just to see the hands-on science and the excitement of our students has been great. And I have a lot of feedback from the students, and I've incorporated it within my presentation because I think that's an important aspect of this, is hearing what our students are saying about what they're learning from this project. I've gone in after each of our field trips, any hands-on activities, to ask them for feedback. And I've asked them for the good and the bad. And I've said, in order to make this program really great, I need to know what you liked, what you didn't like, what you learned. So I've incorporated a lot of that feedback. Another thing that we're doing this week, and so I don't have all of the data on, is we did a survey at the beginning of this project to ask students about their interest in math and science, what they thought they would do in the future in high school and college, whether they would have careers in math and science. So we got a baseline. I'm now doing it at the end of the school year to find out whether they felt as though they have a better understanding of math and science careers, and whether or not they think they've changed their minds a little bit, which is our hope, is that they hopefully want to do more with math and science, and they have a greater interest in it. So you'll see some of that interspersed here, and I looked at some of the data. We've only done about 30 students out of the 100 students that we will survey. So I just, before I came in, I looked at some of the data, and it's very promising. One of the questions I asked them was, do you feel as though you have a better understanding of what mathematicians and scientists do after the SAM's project? And 100% of the students said yes. And so that was great. And, that's very reassuring. And many of them, when I asked that question in, I think we did the survey initially in October, when I asked that question, 48% of them said they knew what mathematicians and scientists do. So, again, I think that's a very positive thing to sort of latch onto. So this, I won't go through this again in detail, but this was the same slide that I showed you at our last meeting. And I talked in April about, here's what we're going to do. 6th grade studied aquaculture, hydroponics, endangered species, sustainable farming. The diamonds there are our milestones. So we had a field trip to Roger Williams University, a field trip to the Matunic Oyster Farm. We had a speaker come in on oyster gardening. We had a speaker from the Roger Williams Zoo. We had a field trip to Watson Farm. 7th and 8th grade did a study of electricity, and that was a new unit of study in the 7th and 8th grade. We did not have that unit of study before. Jim Kaczynski, the 7th and 8th grade science teacher, actually went to a training on it, and he built electric motors and compasses with the students. That was entirely new to our curriculum. The culminating factor of that was a field trip to the Boston Museum of Science, where they have a very amazing electricity show that tied in very well with what Mr. Kaczynski taught the students. And what they're doing now is they're beginning a unit on renewable energy and building solar cars, and starting to understand, well, how do you use the sun's power to generate energy. So there's a lot here, and a lot of field trips, a lot of presentations. So what I'd like you to do is just imagine that you're on these field trips with us. And I'm going to show you a bunch of pictures. I know the pictures don't accurately represent what really happened, but I hope that you'll get a feel for what we did, and you'll see what our students had the opportunities to have hands-on experiences with. This is in the classroom, and I apologize, it's a little darker than I hoped, but what I really want to demonstrate to you, this is Deb Barone, the 6th grade science teacher, with her new smartboard, which was brand new as part of the SAM's project, and it's something that she's able to use within her classroom to teach using presentations, whether they're PowerPoint, using the web, but really she's been able to utilize her computer while she's teaching. The students are able to get up there and touch the screen, do a lot with it. So I just wanted to show you that. That's one thing that and she's really used it quite a bit. I think last time when I was here I spoke to you a little bit about the terrariums that students, again in 6th grade in Deb Barone's class, actually created. And what these are, I just want to point it out to you so it's not all that clear, but these are two soda bottles put together. On the bottom of these soda bottles are guppies. You can see these little orange things down here. These are actual fish. On the top of these, they actually grew herbs. And this is a self-sustaining system that they have where the nitrates from the water of the guppies are actually used to feed the plants. Each student created one of these as part of their really it's aquaponics. So they did a combination of the guppies and the herbs that they planted. So that was small scale. Each student had it. Our hope is in the next year that we would have a larger scale version of this. And so here's a larger tank on the bottom with the pumps that pump up to feeding plants.
We don't have that though.
We don't have that. This is something that we're planning to install this summer and have up and running for the fall. The field trip that we took to extend what we had learned in the classroom was to Roger Williams University. Roger Williams University, and this was new to me. I didn't know a lot about what they had, but they really have a world-class marine sciences program at Roger Williams University. It is only for undergraduates, and it's an interesting fact because the fact that it's only undergraduates means that undergraduates have the opportunity to do research that oftentimes in larger university settings, that's exclusively graduate students that do this. So our students had an opportunity to see undergraduates a little bit closer in age to them and doing the real life work in these labs. Roger Williams University just got, I'm not sure exactly how much money, but stimulus funding to build a whole new lab. And this is their lab. One of the things a couple of things that they do there is they breed clownfish, they breed seahorses, and they breed what are called peppermint shrimp. And these three species are very difficult to breed because they require a certain temperature of water, a certain salinity of the water. So it is complicated. There are very few places that do this. And Roger Williams is sort of looked at as a world-class place that does it. So we had a unique opportunity to see their environment. They actually are located right on Mount Hope Bay. So they bring in the water from the bay. They actually pump it in and they cleanse it and get it warm and different things like that to get it ready for this environment. But they are able to breed their seahorses. And we saw the seahorses there. We learned about seahorses, we learned about clownfish. And we also have 4 seahorses in the 6th grade classroom and 6 clownfish that were bred there. So we were able to see the mother and father seahorse that our seahorses came from. So that was exciting to the students. The comment that came back on one of our surveys was, I like finding out where our seahorses and clownfish came from and how they were bred. Again, at Roger Williams University, when we went in, the people in the lab, when I went to talk to them first and said, look, we don't want a field trip where we just walk by and you talk to us. We want something where we're hands-on, we're doing jobs. So when we got there, they had a big whiteboard outside the lab, and it said, welcome Jamestown Schools, and it had a list of jobs. And it said, these are the jobs. And the woman that took us through the lab said, this is what I do for my students. There's a list of jobs each day when they come in of things that need to be done in the lab. So right here, our students are actually taking these shell bags and they're putting them in these tanks where the oysters actually hatch. So this is the oyster hatchery, which is at Roger Williams University. Another thing that we did is Roger Williams University has these giant 200-gallon tanks where they grow the algae and plankton that they feed the oysters. Our students had the opportunity to look, so they examined the algae. They did some counts on the algae. They actually had to determine whether the algae was small enough for the baby oysters, and then as the oysters get bigger, they get bigger pieces of algae. So they were examining that under the microscopes. Again, something that the students do when they work in these labs. This is again one of the lab technicians showing the oysters in their hatchery. Here are our students, and they had real jobs. So they were taking the algae out of the large tanks and bringing them into the oyster hatchery and pouring them in. And you can see students in the background actually doing the same thing. They all had jobs to do. We broke them up into groups of 6 or 7 each, and so that they were in different parts of the lab, but each of them had jobs to do. And here's the comment that I got back. I liked having real jobs to do in the lab. I wish there were more jobs for us to do.